We talked about the behavior of OSPF inter-area and external routes. So let's now take a look at how these routes are represented in the OSPF database. So what we are going to do now is we are going to continue with the network example that we built some long time ago. And we are going to expand it. I'm going to add some routers and I'm going to change couple of things there. So you might remember that we had a network that started very simple with the connection between routers R1 and R2, and then we added routers R3 and R4. So this was all configured and this was all operating in area 0. So let me put in the relevant bits of information here. So this is gigabit interface 1 here, and we have 192.168.12.0/24 is the network there. We also had the loopback on R1, and this network here was 192.168.134.0/24. This was gigabit interface 2 on all three routers here. And as I say, everything here was running in area 0. So what I'm going to do now is I'm going to add one more router, and it's going to be router R5, and this router R5 will be connected on gigabit interface 3 here, and it's going to be behind the network 192.168.45.0, and it's also going to be /24, and I will also add the loopback on this router. So routers R3, R4, R1, and R2 were all operating in area 0, but this is something that I'm going to change now. I'm going to make my router R1 an ABR, and I will make my router R4 an ABR here. So I'm going to divide my network into really three areas. I'm going to have routers R1 and R2. They are going to be in area 12. My routers 1, 3, and 4, they are going to be in area 0, and I'm going to have routers 4 and 5 here. They are going to be in area 45. And just as a reminder, all of my routers will be configured to have the router ID in the format of 000X, where X is the router number, so 2, 1, 3, 4, and 5. So this here is router R1. So I have almost all of this stuff configured. So what I have to do is I have to add the link between 4 and 5, establish the OSPF there, and I have to change the connection between routers R1 and R2 to be in area 12. Now I have the loopback of R1 here. It doesn't matter in which area I put it, but I'm just going to move it here on the drawing to leave it in area 0. It is going to give me the minimum configuration that is going to be needed. So let's head to the terminal and take a look at this. As you are used to by now, the first thing I'm going to do is I'm going to make sure that the connection between 4 and 5 is actually operational. So here I am on R4, and I'm going to say show IP route connected, and what I'm looking for here is this link 192.168.45.0. I want to see it on gigabit interface 3, and I want to make sure that I can ping my R5, and from R4 I can ping R5. So I'm going to head to R5. I'm going to say show IP route connected. I do see that I have a gigabit interface, but what is missing is the loopback interface that I promised I will configure. So I'm going to say IP address 192.168.0.5.255. So there it is. So if I do show IP route connected, this is what I'm going to have now. And let's make sure that from R5 I can ping R4, and I can. So let's go to R4, and what I want to do now is I want to go into my router OSPF process, and I want to say network 192.168.45.0.255 area 45. And just to speed things up, I'm going to go to the gigabit interface 3, and I'm going to say IP OSPF network point to point. On R5, I'm going to say router OSPF. Actually, let me start with gigabit 3. I'm going to say IP OSPF network point to point, and then I'm going to say router OSPF 1. I'm going to say router ID 5, I'm going to say network 192.168.0.5. This is for the loopback area 45, and I'm just going to say 45.0 here, 255 in area 45. So I should be seeing OSPF coming up at this point. I'm then going to head to, let me see where would be the best place to start. I'm going to head over to R2. And what I want to do here is I want to change, oh, I forgot to change the auto cost reference bandwidth. That's very important. So let me head to R5 here and just add this. So I'm going to go to R2, and what I'm going to do now is I'm going to change this network here to no longer be in area 0. I want to change it to area 12, and I want to do the same thing here on R1. I'm going to remove this and change it to be in area 12. So now that I have configured all this stuff, let's verify that it is actually configured the way I would like it to be configured. To do that, what I'm going to do is I'm going to start from R2. I'm going to verify that this interface is enabled for OSPF. I'm going to make sure that I do have the neighbor with R1 in area 12. Then I'm going to move on to R1. I'm going to make sure that I have the neighbor with R2 in area 12, that my loopback and gigabit 2 are advertised in area 0, and that I have neighbors with 3 and 4 here. And you might remember that in this setup here, R3 is our DR, even though it's not going to be relevant for anything, but just as a reminder. Then I'm going to go to R4 and make sure that I have my interface gigabit 3 that is enabled for OSPF, and that I have a neighbor with R5 in area 45. And finally, I'm going to make sure that the same thing is true on R5. So let's start with R2. I'm going to say show IP OSPF interfaces brief, and what I'm looking for here is a single interface in OSPF in area 12, and that's exactly what I'm seeing here. I have gigabit 1 in area 12, and I can see here at the end the output that says neighbors 1/1. That means that I'm fully adjacent with one neighbor with out of one neighbors that I actually see on the interface. So one adjacent out of one neighbors that I see on the interface. And comparing that with the network diagram here, that's exactly what we are expecting to see. So let's move on to R1. On R1 here, show IP OSPF. Okay, let me do it like this. Show IP OSPF interfaces brief. What I'm looking for here is on gigabit 0. On gigabit 2 interface here, I'm looking for 2 neighbors, and I can see here that I am fully adjacent with one neighbor out of 2 neighbors that I see. Now this is okay, because remember, this is R1, and here we have the connections with R3 and R4, and R3 here is configured as the DR, and we have explicitly configured no BDR. So R4 will be DR other, and R1 will be DR other on this segment, which means that there will be no adjacency between them. They are going to have a two-way relationship, but we are going to be adjacent only with R3. So if I take a look at show IP OSPF neighbors, this is exactly what I'm expecting to see. I can see that I'm fully adjacent with the DR, which is R3, and I'm in a two-way relationship with R4. This is something that we have already went through earlier, but now I'm just confirming that this is indeed the case. Now I'm going to go to R4, show IP OSPF interfaces brief, and here I'm just going to focus on gigabit interface 3, and what I'm looking for here is that on gigabit interface 3 I am in area 45, and that I'm adjacent with one neighbor out of a single neighbor that I see on that interface, which is R5. And finally on R5, show IP OSPF interfaces brief. Here I expect to see 2 interfaces, the loopback and the gigabit 3. That's what I see. They're both in area 45, and I can see that on gigabit 3 I am adjacent with one neighbor out of one neighbor that I see. Now that I have the setup the way I wanted to have the setup, let's take a look at our type 3 LSAs and our external LSAs in the network. to do that, we have to focus on something. So what we are going to focus our attention on is going to be the loopback of R5. So this is the network with the address 192.168.0.5/32. Now, we know that in area 45, this will be communicated as type 1 LSA to R4. But we also know that R4 here is an ABR, and we're going to confirm that by looking into the database of R4. So what we expect here R4 to do is to generate the type 3 LSA, which will propagate in area 0 to R3 and R1. R1 is also an ABR, so we would need to take a look at what happens there, and we are expecting R1 to generate its own type 3 LSA and inject it into area 12, where R1 is the ABR for. So let's take a look at this. I'm going to start with R5. So what I'm expecting to see here, if I take a look at show IP OSPF database router self-originate, what I'm expecting to see here is I'm expecting to see the loopback advertised as the internal route. So this is just a very quick confirmation that this is indeed the case. So if I go to my R4, if I do show IP route OSPF on R4, what I'm expecting to see here is the route for 192.168.0.5 to be an internal route. And I can see this is an internal route here because it simply says OSPF. If this was an inter-area route, I would expect to see this as IA, and if this was an external route, I would expect it to see as either E1 or E2 for type 1 or type 2 metric, or if this was an NSSA route, I would expect to see N indicators here. If there is no indicator here about specifying something more specific and we just see the uppercase O at the beginning of the output, this is showing us an internal route. So on R4, we do have this in our own database as an internal route. But if I take a look at show IP OSPF database, so I'm going to just look at the summarized information of the database, I'm going to get now a lot more output because now I have the database for area 0 and for area 45. Let's take a look at just the database for area 0. So the command to do that would be show IP OSPF database process number 1 0 database. Now this 0, show IP OSPF 1 0 database. I do apologize about that. So this syntax here simply means show IP OSPF for process 1, show me the database for area 0. And here it is. We can see that this is only showing me information about area 0. So let's take a look at the area 45. For example, for area 45, what we are seeing here are two type 1 LSAs, one generated by R4, one generated by R5, with a certain number of link counts. We have already talked about this. Now, in the summary net link state here, I'm going to have some inter-area routes, yes, but what we will not have here is R5's loopback, because R5's loopback is an internal route. But if I take a look at the database for area 0 here, for the database of area 0, I will indeed have the information about this loopback. Now, what I'm going to be seeing here is that there is this link identifier, and we can see that the link identifier for type 3 LSAs will be the network advertised, and we are going to see the advertising router 0004. So let's take a look at this LSA in a little bit more detail. So if I do show IP OSPF database, and I can say summary. Now, this summary is not going to show me the summary of the database. If you want to see the summary of the database, you actually have to say database/summary. So if I do command show IP OSPF database summary, this summary here is the keyword that tells OSPF that I actually want to see type 3 LSAs, which are called the summary LSAs. And here I can specify either the LSA ID or the advertising router or the router or those LSAs generated by myself. What I want to take a look at here is the loopback of R5. And here it is. Here is the type 3 LSA that is generated by R4. We can see here that it says the link state identifier is 192.168.0.5, and it simply says that this is a summary network number. It kinda, iOS is helping us determine what this is, and here is where we will have the mask, and we have the metric 11 here. Why metric 11? Well, if we go back to our diagram here, we know that the loopback will have cost 1, and we know that these links here with our changed auto cost reference bandwidth, they have cost 10, so the cost from R4 to reach the loopback of R5 is indeed 11, and this is what R4 is going to be injecting into Area 0 database. So let's now head to R1 to see this LSA in the database there. So I'm going to say show IPOSPF 1.0 database summary 192.168.0.4. So, sorry, 0.5. So what I'm going to be seeing here is going to be the exact same information that I had on R4. So here is the information on R4, here is the information on R1. There is going to be one significant difference though. I'm going to have this information here that says that there is a routing bit set on this LSA. You can ignore this topology base here because this is, again, added in relatively recent versions of iOS is support for something that Cisco calls the MTR or the multi-topology routing. This is not something of the concern for us at this stage of learning. So routing bit set on this LSA simply means that OSPF thinks that this prefix should go into the routing table here. So now we can see that this LSA here is absolutely the same as the one that was injected by R4. But let's take a look at this same LSA now on R2. If we take a look at our network diagram, R2 is in area 12. So what we should be seeing here is the LSA coming from R1. But what is going to be the cost on this LSA? What do you think? Well, let's try to calculate. We know that R4 is advertising the cost of 11. So what is R1's cost to reach R4? Well, this link here also has cost 10. So what we should be seeing here is the cost of 10, 20, 1. So let's go to R2 and first confirm this. If I do show IP route OSPF, I'm going to see the route for 192.168.0.5, and I can see it's an inter-area route, and I'm going to be seeing it with 31. Why am I seeing it with 31? Oh yes, of course. I'm going to be seeing it with 31 because there is obviously R2's cost to reach R1. But let's take a look at the LSA. Let's see what R1 actually put into the database. So if I go here and if I say show IPOSPF database summary 192.168.0.5, this is what I will be seeing. First thing that I can observe is that this is indeed LSA generated by R1, and here it is the cost 21. So R1 is telling us that its cost to reach this prefix is 21, and R2 is looking at its own cost here on this interface to reach R1. It's adding these two together, and we are ending up in the routing table with the cost of 31, which we can confirm if you do show IP route OSPF again. We can see here that the cost was indeed 31. And this shows us here how R1 actually generated the new LSA. One more thing that I want to show you is, now let's head back to R4, and I'm going to say show IPOSPF database router self-originate, but I want to take a look at the database in area 0 here, and I want to show you this part of the output here. Now when we have configured our R4 with interfaces in area 0 and in area 45, R4 automatically regenerated its type 1 LSA and is now claiming to be an ABR. The same thing we can observe on R1 if you do show IPOSPF database router self-originate. So I'm now going to look into the database for area 0 and for area 12. So in area 0, so here is the output for area 0. This happens from time to time. I do apologize about that. So here is the output for area 0, and we can see here that R1 is claiming to be an ABR in area 0, and also now we can see here for area 12, R1 is also claiming to be an ABR. The same situation is with R4. So for R4, if we take a look at both databases here, for the self-generated LSAs, we can see here that in area 0, it is claiming to be an ABR. There it is. And we can see here that it's claiming to be an ABR, and here for area 45, it is also claiming to be an ABR. So we can see that this B bit that is being set on the LSAs is going to be sent into the all areas where the router is connected to. Let's head back to our diagram here, and now I want to add a loopback interface on R2, and this is going to have an IP address of 192.168.02/32, but I don't want to advertise this into OSPF. What I want to do with this loopback is actually I want to redistribute it into OSPF. So what I'm going to do here is I'm going to show you a couple of things. The first thing that I'm going to configure here is going to be a very simple filter, and I'm going to use the route map with a match interface statement, and then I'm going to show you how to redistribute the routes in OSPF. And then what we are going to look at here is how this external LSA is going to propagate through the network all the way to our R5, and then we are going to see how R5 will calculate its reachability to this loopback. Let's head to R5 then, and I'm going to add my loopback interface here. So I'm going to say IP address 192.168.0.5. Oh, actually, not on R5. I do apologize. We want to do this on R2. So I'm going to create the loopback interface here, IP address 192.168.0.2.255, and then I'm going to create a route map, and let's call it connected to OSPF, permit 10, and I'm going to say match interface loopback 0 here. Then I'm going to go to router OSPF1, and I'm going to say redistribute connected. And for OSPF in iOS, it's important to remember that you do want to use the subnets keyword. If you don't use the subnets keyword, you are going to be redistributing only classful networks from a particular routing source. In our case, routing source is the connected routes, but we do want to redistribute the subnets of classful networks. So that's one of the quirks of working with code as old as iOS is, that you have some of this stuff that should have been long gone from iOS years, decade ago, but we are still stuck with it. And then I'm going to specify here the route map filter. Let me bring this up, or connected to OSPF, because this is the only prefix that I want to redistribute. Now, what I want to do now is I want to say show IP OSPF database, and I want to take a look at the external prefix in my database. Now, I'm going to observe several things here. First thing is that the link state ID of this prefix is 192.168.0.2, which is the same as the network that has been redistributed. This will always be the case. And I can see here that I have the mask. Also, I have the information that the advertising router is 0002. Let me now head over to all the way to R5. So I'm going to go to R5, and I'm going to repeat the same command, show IP OSPF database external. So here is the output on R5, and here is the output on R2. R5, R2, R5, R2. If we ignore the routing bit set on this LSA, and here is this problem again, if we ignore the routing bit set on this LSA, if you ignore this line here, if we compare the output of R2 with the output of R5, we are going to see that they are fairly identical. What we are looking for here is that the metric is the same as it was advertised from R2, and we can see here that the advertising router still indicates R2. If we take a look at our show IP OSPF database on R5, if we take a look at router link states, if we take a look at type 1 LSAs, we don't have any information about R2. But here it is. This is the summary ASB link states. This is type 4 LSA. Type 4 LSA that will help us reach from R5 all the way to R2. But let's not jump ahead. Let's take a look at what is happening on R1. So if I go to R1 here, if I do show IP OSPF 1 and 12 database, in the database for area 12, I am not going to be able to see my type 5 LSA. Remember, type 5 LSAs are global for the entire domain. They do not belong to any specific area. So if I take a look at the area 12 database or area 0 database, I am not going to see any type 5 LSAs. If I want to see them, I would actually have to look at the entire database because they will be shown here at the very end of the output because they don't belong to any area. And you can see here that for all the other LSA types, you have an indicator to which area they belong, but not for type 5 LSAs. Type 5 LSAs are global for the domain. And here on R1, I see this LSA. Now, I can also, if I take a look at show IP OSPF 1.0 database, I can see that R1 generated type 4 LSA in area 0, where it's basically saying that router 2 can be reached through router R1. Now, this information will be used by my routers R3 and R4 to reach R2. But remember, or you might remember, when we talked about how this information is propagated, I did mention that on R1, the generation of type 4 LSA wasn't triggered by the arrival of the external prefix. It was actually triggered by R2 claiming to be ASBR by setting E bit to 1 in its type 1 LSA. Let me show you that. So if I take a look at R2, if I do show IP OSPF database router self-originate, what I'm going to see here is a piece of information that says that this is AS boundary router. This basically means that this router is setting E bit to 1. Now, if I go to R1, this information has triggered R1, it has given information to R1 to generate our type 4 LSA, to generate this information here. Now, if I go to R4, for example, if I go to R4 here, on R4, the presence of type 4 LSA is the one that actually tells R4 to generate its own type 4. Let me show you that. So if I do show IP OSPF 1 database, ASBR summary, so I want to look at just type 4 LSAs, I'm going to see two type 4s. One of them will be in area 0, this one here, and this will be the one that was generated by R1. Now, this other type 4 LSA here will be in area 45, and this will be the one generated by R4. Now, I can see here, so this one above here, this metric here that I'm observing, this is R1's cost to reach R2. It says here 10. Shouldn't it be a little bit more? Well, no, because if we have R1 and R2 here, R1's cost here on this interface is 10. This is not the cost to reach any particular interface on R2. This is the cost to reach the actual device of R2, the router ID of this device, which is not any interface or not any IP address. So R1 claims cost 10, and R4 says my cost to reach R2 is 20. So if we take a look at R4 here, now we know that it's connected on this multi-area segment, but R3 is not really relevant in this story. The cost of R4's interface here is 10, so we have 10 plus 10 equals 20. So this is how we end up with this cost 20 to actually reach from R4, R2. Now, behind R4, we have our R5 here. Now, R5 has cost 10 on this interface as well, and here we have the external prefix, our loopback 0. So what is the cost on R5 to reach the loopback 0? Let's take a look. If I do show IP route, OSPF, I'm looking for an external route, and there is my external route here, 20. This is a little bit confusing. Well, it isn't when you come to think about it. R1, or actually R2, the router that injected this route with the actual metric. So let me take a look at that external prefix. There it is. So here is the metric. This is the metric that was injected by R2. We can see here that it says metric 20. Now, this is type 2 metric, and it says this is larger than any link state path. Now, what type 2 metric says here, and we are going to look at R2 now, is there is an external cost to reach this prefix. By default, it will be 20. With type 2 metric, this is the only, or actually the most important thing that matters. That means that if we had, let's say, some R6 here injecting this same network for some reason, and it was injecting it with the external prefix, or with the external cost of 40, we would prefer this path over this path, regardless of what was the actual cost on the inside to reach these two ASBRs. That means that the external cost is more important to us than the internal cost. Now, this doesn't mean that this internal cost is completely irrelevant. If this here was equal, in that case, not this, if this here was equal, if the external costs were equal, that doesn't mean that this router here, let's say that this is some fictitious R7, would load balance over these two paths. It won't. It would actually look at the internal cost as well before it load balances over these external paths. Now, this other piece of information is not going to be immediately visible in this output here. So we cannot see what is the internal cost to reach the ASBR with this output, but what we can do is show IP route 192.168.0.2, and if I take a look at this output here, the forward metric, this is the cost from R5 to reach R2. This is the internal cost. For type 2 metrics, for external type 2s, the forward metric will be shown separately from the external cost, because external cost is what matters more. Let's change this to be type 1. And the easiest way to change this would be to actually modify our route map that we already have here. So I'm going to go into the route map, and I'm going to say set metric type 1. Now, with this little change, if I do show IP OSPF database external, I will see now that what is going to be inserted into the database by R2 is going to be type 1 metric. It is still going to be 20, but if I go to my R5 here, if I do show IP route 192.168.0.2, what I'm going to see here now is metric 50. It's going to show me the actual calculated metric. It's going to add this value to this value, and it's going to show me the calculated value. I can see that the metric hasn't actually changed. I had the external metric of 20 and the internal metric of 30, but now it is going to be shown as a single metric. And this is what external 1 routes do. With external type 1 routes, what we have is that the internal cost is treated equally to the external cost. With type 2, external cost takes precedence over the internal cost. Let's now make one more change in our network. I'm going to now modify my area 12 here. So let me delete this area 12 here. I'm going to change my area 12 to be the NSSA area. This is the only change that I'm going to make, but I have to make this change on R1 and I have to make this change on R2. I'm going to start with R2, so I'm going to go into my router OSPF 1, and I'm going to say area 12 NSSA. As I said, this is the only change that I'm going to make. Now, when I do this, I will see that my adjacency is going to go down, and on R1, I don't see it go down yet because I have to wait for 40 seconds to elapse, but R2 has already torn down the adjacency. So let's help R1 a little bit. So I'm going to say clear IP OSPF process. And I'm going to say area 12 NSSA there as well. And I'm going to wait for the process to come up. I can see that this is indeed the case. So if I do show IP OSPF neighbors, this is pretty much the output that I want to see. Now, if I go back to R2, if I do show IP OSPF database external, I'm no longer going to see any LSAs there. Now, I'm not going to see any LSAs because show IP OSPF database external is going to show me redistributed LSAs into the OSPF domain that are injected into the database as type 5 LSAs. Type 5 LSAs are not allowed in the NSSA area, so what I'm going to have here are going to be type 7 LSAs. So if I do show IP OSPF database, I'm going to see type 7 AS external link states here, but remember how type 5s were not tied with any area. Type 7s actually are, because they are part of the NSSA area. And I will see here that I have the link identifier and the advertising router, just the same as I did with my type 5 LSA. Now, if I go to R5, all the way to R5, remember our diagram here. So now I'm on R5. If I take a look at show IP OSPF database external, here I will actually have an external LSA. Now, the problem here is that I'm seeing two of them, and one of them is a stale one. So I'm going to do something that I should have done before. And this is actually, I'm just going to clear the OSPF process on all of my routers, because what we are going to be seeing otherwise are going to be some of the stale LSAs, and that doesn't really provide for the best learning experience. Now, this is not something that you should be doing in the production environment, obviously, but it's okay to do it when you are learning, when you're studying the protocols. It's an efficient way to get rid of the stuff that you don't really want to have. So I'm going to do again show IP OSPF database external, and now I will be seeing just one LSA here. Now, what I'm seeing here now, oh, this is still the old one, huh? Why am I seeing it? Shouldn't be seeing it. Let's clear the, on R1, oh, it only came up now. Okay, let's see if, oh, I'm still having two. So what I have to do now is I'm going to cheat a little bit. I'm going to stop filming me now. I'm going to clean this up, and then I'm going to come back. I promise I will not be changing any configurations. I'm just going to clear the OSPF processes. Okay, I lied. I didn't stop recording because I didn't want you to take my word that I am not going to change any configurations. I did speed it up a little bit. I hope you understand that, but I have not changed any configurations. I just waited for things to settle down so that I can show you how it's going to look in a stable environment. You really, when you are learning, it's very, very easy to get sidetracked with the transient contents of the database, and this is not what we want to do. So now I am back on R5, and I'm going to run show IP OSPF database external. Now what I'm going to be seeing here is going to be a type 5 LSA, and as we can see here, this type 5 LSA is not part of any area. It is the global in the database, and I can see now that it was actually advertised by R1. Now remember that R2 was the router that advertised type 7 LSA to R1, and R1 is now actually accepting this LSA, and it's translating it into type 5 LSA. So R1, in a sense, becomes an ASBR. Let's take a look at that. So I'm going to go to R1 now, and promise, if I take a look at the OSPF process, there is no configuration here of any redistribution. If I take a look at show IP OSPF database, show IP OSPF 1.0 database, router, self-originate. So I'm going to look at type 1 LSA that R1 injected into area 0. What I'm going to be seeing here is that it's claiming to be an ASBR. In other words, it is setting the E bit to 1. Why is it setting E bit to 1? Because otherwise here R5 wouldn't know how to reach R1. What I didn't show you is that we are going to have a type 4 LSA generated by R4 for R1 on R5. So let's take a look at that. So I'm going to say here, show IP OSPF database ASBR summary, and here it is. R1 reachable via R4, and this was generated by R4 here. So we can see here that R1 actually translated our type 7 LSA into type 5. There is one more interesting thing about the NSSA areas, and that is when we have multiple ASBRs multiple ABRs in the NSSA area. So let's take a look at the example that might look something like this. So we have R1, R2, R3, R4, and let's say that this here is our area 123 NSSA, and that R1 here is redistributing some network here. That means that our R2 and R3 routers are NSSA ABR. So this is an ABR and this is an ABR. Now, when this type 7 LSA is learned by R2 and R3, you would think that both of them would actually provide the translation service. They won't. Only one of them will translate, and that is going to be dependent on the router ID. So let's say that this one here has the router ID that is 0002, and this one here has the router ID that is 0003. Now, the translating ABR will be R3 because 0003 is actually higher than 0002. Keep in mind that R2 and R3 do not have any direct relationship. They are not directly connected. This here was just me indicating that there is a boundary. There is no link between them, but they know about each other because they are sharing the database in area 123 and they are sharing the database in area 0 here. So I didn't write that, so this here is area 0. So they know about each other even though they are not directly connected, and they're going to have this simple selection of who is going to be the translating ABR. So only the router with the highest router ID of all the ABRs, even when we had multiple ABRs here, let's say that all of these were ABRs, only one of them will be performing the translation, one with the highest router ID.